Hi, welcome to Driven by Me and Thesis. And tonight I'm going over the placeholder and base mesh. So the base mesh usually is when you do 3D character in games, you will make the head to toe character and give it to level designer to use, but it would be like a model, anatomical model of the character in the game, and usually not animated, but you can, if you can do it fast. The base mesh will be used as a placeholder. What are placeholder? Placeholder, which is also called placeholder art. As the same as the base mesh. They are used to by the level designer and level artist, depending on the studio where you work or the team. Because in some studio, the larger the studio, the more defined the jobs are. So if you are in a small studio, you can have like one person doing level art, level design, game design. But the larger the studio, the more precise the jobs are, and the more jobs, different job types are. So sometimes it will be used by a level designer, which would be different from level artist. If you want to know more about level designer, I have this channel. This guy is just teaching level design, so it was very good. What I've seen so far, he was getting to the point. There he talks about the placeholder art. So you would, like, as an artist, you would give a very fast block out of your character to the level designer or level artist to use in their blocking. So let's see how if he use it. There he is making a block out of the scene with placeholder art that he sometimes the level designer will create his own, waiting for the artist to finish what needs to be put there. So let's I didn't watch the video, so I won't watch it with you. I was just wondering what he would say about it. So I will start by doing base mesh for what I need now. So in my roadmap, I will stop the character concept art right where we left the 9, and then start today at least one I don't know why it didn't. It doesn't want to end on 10 here. Anyway, so let's start with the modeling. I will do which one I will do. I need to do the three of them, both of them, all of them. Right now, I think I will go with the cards. So I won't take it until I'm not done. So let's start with that. Okay. How would you do that? Then I will do it as if you don't have, since you don't have, probably don't have RotoPoFlow, which is a paid add-on in Blender. I will show you how to RotoPoFlow with the vanilla Blender. Vanilla version, which means the version without add-ons. So I don't need to remove that. I need to go back to I think I didn't open the right Blender version. I don't remember which one. See, yes. I forgot the chat. So we'll just type okay. So I'm not sure yet about what would be my game design, but just for the sake of showing you 3D modeling a bit, I will do it in 3D for now, but that might not be my final go-to for my own game style for this game. So let's go back to this was the French live stream. I did the Robotniks. So let's go back to our guy. And then usually the Basemesh, it can be with the clothes on. It can be the anatomy. It can be very fast. That way the game designer have the correct height of the character, which will preferably be written in the technical design or the game design document, depending on how you structured it. But for me, how I would like to put it, I would put it in the technical, because I would prefer to separate anything that is not technical for the team within the production, inside the GDD, and everything else that is for production inside the technical document. As for the height of the character, I would put it in the TDD because it's for production. So what can I do? I would do fast. I would say, like, let's say this is finished, but it's not. But let's say as if it was finished. How would you do a fast? The fastest way to do a base mesh? It would be to be secure. Do an iterative every new day at least. That way you can go back, you have a version you can go back if you mess up today. And then I would merge them. So select both. I'm not pro yet with Blender, but I know this is I need to select them both here, not in sculpting, and join it, and then go back to sculpting. Then I can do either way, Control R or the modifiers, and the modifiers would have worked if I Control Z, Control Z, Control Z. With the modifier, you can merge them, which would be might be better if you don't want to lose some details. And this is Boolean. To merge them, you can extract the shape of one from the other. You can do many things with Booleans. It's like Booleans are logic gates, with which you can do subtraction of shapes, additions of shapes. It can be used. It's used in many things, like in programming. The logic gates are the simplest element of a computer that do the arithmetic for calculating, like behind a calculator. The logic gates are used. You can play a game that would make you understand how it works. It's called I didn't share my screen, I forgot. So at least I didn't went too far into it without the screen. It's the game is called Turing Complete, and in this game you do a circuit, you do a computer with logic gates, with N and R and Booleans calculations. It's very cool, very nice game. You do it becomes very complex at some point. You do a whole computer, and I think it's made in Godot, if I remember. You do a computer, all what the computer chip does. So you start very simple, and it becomes more and more complex. And this is the same principle behind Boolean. Boolean arithmetics. Let's see, Turing complete wiki. Turing is from, the name is from Alan Turing. Something that is Turing complete is I don't remember exactly. Turing completeness is used as a way to express the power of such data manipulation rules that virtually all programming language today are Turing complete. It's some kind of confirmation of the computational thing. So you can say, is a language Turing complete or something? I don't remember exactly. It is Turing complete if it can simulate any Turing machine. And you go to look what is a Turing machine, the mathematical model of computation describing an abstract machine. I just wanted to know game engine if it was made in Godot. Game made in Godot. Yeah, I think it's made in Godot. I saw it in trailer of Godot. Made in Godot. Oh, good. We can do a game that is that good in Godot. So the Boolean and logic gate. So you can have a picture of the result. You have tables like input is, this is just yes, so the input is 0, the output will be 0. If the input is 1, output will be 1. So there is a current, electric current passing through. If the current is like 0.5 volt, it means 0 pass. If it's 1 volt, it goes out at the same. But this one, it invert the electric charge. And then you have end, and we'll do 0 and 0 will give 0. 1 and 0 will give 0, but 1 and 1 will give 1. R would be, so it's the same thing as when you do a condition in programming, and you have false and false will give false, true and false will give false, because there is one false. But if there is no false, everything is true, then the answer will be true, the output will be true. Or will be false or false, it will output false. True or false will output true, because there is one true. When you program a condition, if statement, you always do this, and then you can do this with the pixels, and you have you have this with pixels. Then when you do shaders, you do use the same principle to make masks in shading and shaders. It's the same principle. And then in 3D modeling, you have this add a marching cube, marching cube. I think it's the name. Marching something. Marching cube is a computer resolution 900. Let's see in Blender. How to use Boolean modifier in Blender. What is marching cube? 3D render. Let's remove that. Marching cube algorithm. The thing is, we engine are not render in marching cube, but you can do an engine. But the one we use usually are not in marching cube. You can tweak Unity to make it. Like there, he is doing it in Unity. And the thing with that, I think it's not the issue with marching cube. I think you cannot animate it. It's a bit the same reason why voxel you can't animate voxels, and the reason why the for quite some time the trees in Minecraft didn't fall, except if you download some kind of plugin that will swap the marching the voxel for something else with gravity. Marching cube algorithm. It's easier to cut in parts with the marching cube. I think that when you do Control R, it uses marching cube in Blender because it's easier to cut through this. I've seen a video that was very well explained. I don't know if we can. I can't find. You can do a lot of procedural terrain that you can like Minecraft a bit, but less blocky. So if this is the kind of thing you would like to do in a game, it's marching cube algorithm to carve into a terrain. Often it's used to make the clouds in the sky in some engines. Don't remember the video. It was like marching cube revolution or something game, Blender. Oh yeah, it was something with math. But like math, 3D modeling. Would have saved it somewhere, but trying to find it now. Remarching, yeah. Yeah, there is remarching. That's marching. Don't know if I've seen this one. SDF to assign distant function. It's the yeah.
It tells you how far away. Say they were given this.
It's another way to render that allows to merge easily two things, multiple objects into.
When using distance fields instead of traditional polygons for procedural
modeling,
this
one.
It is important to have analytic and efficient formulas for our primitive objects. Boxes are particularly useful for describing human-made structures. So let's get a look to how one goes about deriving the formula for the distance field of a box. We are going to work with a 2D box centered at the origin. If a box is located somewhere else in the scene, and that can include some rotation, then we will simply transform the space accordingly before evaluating our distance field. So let's give this box a size of Rx times Ry. I am not using the length and the height of the box.
I want to watch it. If you want to watch it, search for SDF, assign distance field. It's another way to render object, and it allows to merge them very easily into each other. So SDF or Blender. Let's see if I can find it. Launcher SDF. So let's check Contour SDF. So when you use SDF, it allows you to merge shape, 3D shape very fast, at a very fast. But it's not the traditional 3D. It's mathematical 3D. So the topology, everything like that, I don't think you have it. So that's it. Oh, it's this guy. It's this one. The one I told you that I wouldn't find. Now I find it.
Fields or functions.
That's this one. I would listen to it up to the end because it's very interesting. Maybe in super fast.
distance fields or functions. You may or may not be aware of a new interesting add-on being developed called Conjure SDF. I'm pretty sure I've shared it in a previous community roundup video, but I want to take a bit more time just to let you know about it because it seems like something that will be extremely useful for modelers of all different kinds. I think it might be quite revolutionary for hard surface concept artists, for example. And when we talk about it, you might learn a little bit more about the fundamentals of 3D modeling. But before we get into it, I want to let you know that this video is sponsored by a member of our community. This is the first time we're ever doing this, which is quite exciting. Spencer Magnuson, a add-on developer in our community, has decided to sponsor this video, and if you stick around until the end, I'll tell you a little bit more about their projects and you can get your hands on a free add-on as well. That's a really cool thing about our new sponsor system because we're not really focusing on large companies. It means you can get something of value that's relevant to you from the community. So stick around for that. So Conjure SDF is what we're talking about. And if you haven't heard anything about this, SDFs are kind of a different way of representing shapes in the three-dimensional space. It doesn't even necessarily need to be three-dimensional, but for the sake of Blender, we're just going to assume that's a use case. SDFs are a bit of a complicated thing to describe because they are inherently very mathematical. An SDF shape is essentially just a function, an equation, if you like. And the job of this equation is to give the interpreter a value, and the value is essentially just a distance from any given point. When you pass a position into the function, it will tell you how far away that point is from the surface of the object. Now, it's a bit of a weird thing to get your head around if you're brand new to this kind of thing, and I'm probably not explaining it very well because it's not my field of expertise. But what this means is if you imagine that that point is moving around an object and technically scanning it, then because the object is mathematically described, you can get an infinitesimal amount of detail. It's a little bit similar to how NURBS or curve-based modeling works, not in the same way, but with regards to the fact that, like, if I just come over here, with curve-based modeling, instead of working with polygons, you're essentially just describing points.
Okay, if you want to use the boolean, you need to like merge two parts without losing the details. You would need to put it at union, take the picker, and then afterward click the down arrow and apply.
Points along a curve like with vector graphics if you've done 2D graphic design before. So imagine that with this shape here, we got a point at the top, we got a point in the little bevel area there, and we've got a point at the end. And with 2D vector graphics, we would use handles to kind of control the shaping of that curve. But if you zoom into the curve, you'll get an infinitesimal amount of detail, basically meaning that no matter how far you zoom in, it's going to be a perfect curve every time. Now we do have that in 3D modeling. That's technically what NURBS are. We have that in Blender as well, but it's not necessarily been designed for that. But this is how most like computer-aided design softwares work, where the shapes are essentially just mathematical expressions which are added, subtracted, effectively booleaned from each other, depending on which operation you choose, to get a shape. So the concept that I want to drill home here is that when understanding SDFs, shape equals expression, or shape equals function, shape equals maths, etc. So there might be some of you around which are thinking, well, polygons are math as well, aren't they? They're points in a 3D space, they're expressions of mathematics. And the answer is yes, but polygons are a bit different because it's almost like a self-imposed limitation, if that makes sense. Numbers in mathematics are perfect, and they are again kind of infinitesimal. If you take a number like 42, you can put a decimal point and say, okay, 42.00000 onto infinity. We can also have recurring numbers that go on into infinity. We can mathematically describe curves like circles with pi. The mathematical side of building shapes is kind of perfect. With polygonal systems, we kind of took maths and then used it to self-impose limitations. So when we look at shapes, we see facets, which are essentially the polygons. Building shapes in 3D space never had to be that way, but we kind of decided that it should be just because manipulating polygons was convenient, and it was a less complicated way to render complex objects to the screen than describing everything with purely mathematical formulas. And it's not like that was a cognitive decision from the beginning. I mean, there have always been different ways to look at rendering engines. That's why there's not just one type of rendering engine. But what we've been stuck with in 3D art, not just in modeling, but also in texturing, is just the techniques that were convenient for the most use cases for the longest amount of time. And the same thing can be said for texturing as well. Like UV mapping is a pain, and I think we all kind of know deep down there's inherently something wrong with the idea of wrapping a two-dimensional image around a three-dimensional object. It doesn't make sense. It's convenient, it's effective for our use cases, but three-dimensional objects are inherently that. They are three-dimensional, and texture is not two-dimensional. It's a result of the actual physical material and the wavelengths of light we see that are reflected off the surface of an object. When we look at this marble, for example, the grooves in the marble are not wrapped around the surface. They might look like they are, but they actually permeate through the object. So I believe at some point in the future, like with some of these modeling revelations, we're going to get on to talking a bit more about modeling techniques. I believe at some point in the future we'll have a texture revolution. We'll be able to find ways of describing how material not only looks on the surface, but also permeates through objects. And we've kind of already been testing this because, like with my procedural patterns pack, if you've been playing around with some of the presets, we have materials contributed by, I think, Chris James Brindley, an amazing artist, where we combine surface materials procedurally with volumetric materials as well. Well, it's all in the same node graph for things like jadeite materials, where we can actually look through an object while also seeing some of the glossy detail on the surface. But anyway, back to modeling. Hard surface modeling is tricky and annoying, but really most of the frustration comes down to some very common techniques surrounding booleaning. So take, if you will, the classic problem of intersecting a sphere with a cylinder. With our traditional polygonal modeling, we need to be careful with how the vertices and the edges of the two intersecting objects mix with each other. Ideally, we would like geometry to be completely equidistant and preferably quads, but that's not necessarily required. N-gon supremacy gang. So the thing is, a lot of modelers that use Boolean techniques end up dealing with a lot of time-consuming fixing or preparation. It must must prepare the geometry to be perfect for this intersection, or I must fix the geometry afterwards. And there are all kinds of tools to help with that. But it's just painful, and it's inhibiting of creativity. It's not very freeform, and that's why a lot of artists, myself included, like to explore alternative techniques for modeling in Blender, which is why I did a video in the past about the other ways to model in Blender, which I think people found quite surprising, because when people come to learn Blender, they think that, oh, only poly modeling.
The Boolean didn't like the merge, the addition. It takes like 50 megabytes of RAM, 50,000 megabytes of RAM on my computer, like 99% of my RAM. So I will close it and don't use this. I will show you another way.
Or sub-D modeling is the way to achieve shapes, because that's what all the professionals mention. Again, the most useful thing for the longest amount of time for our use cases. But there are lots of esoteric or lesser known ways of achieving shapes, and that's where SDFs come back in. So with the SDF add-on that Joao de Zega, which I probably pronounced the name wrong, sorry, otherwise known as John Kaz Art on Twitter, it effectively lets you take these mathematical expressions of shapes and merge them together with pretty good performance from the look of it, in a way where the shapes seamlessly blend together, and you can change the parameters of these objects afterwards as well. So from the looks of the parameters, the connection points between objects can also be modified in the settings. They've also been working on a way to convert the SDF shapes to meshes, which is also going to be super useful, because that means we can then take it and modify it with our regular Blender toolset. Now, some people will look at this and go, isn't that similar to voxel modeling? What about metaballs? We've kind of been doing the same thing with them before, and that is true, but none of these techniques are exactly the same. There are pros and cons and differences all around. So SDFs are what I would call a virtualized geometry system. Now, I don't know if this terminology is actually consistent with other people in the community, so I'll try and describe what I mean. When you make points in cycles in geometry nodes, like if you're making a point cloud, no matter how far you zoom into one of those spheres, it's going to be a perfect sphere. But it's not real. You can see it, but it doesn't actually exist as an object. Blender doesn't consider it to be an object. This is what I would call a virtualized shape, a virtualized mesh. Something that technically exists, but it doesn't actually exist. Similar to how
I will just show you how I would do then. Instead of using a boolean, if you want to use a boolean, you will need to lower this one, or try to find a mix between the number of polygons between the two shapes. I think it was too much for it to tell to decide how to merge such high-res model into so low-res one. But you would need to lower this one and higher this one. So I would do another way is to join. Let's see if it will have as much trouble. Not this. I will go to just a second, sculpting. And then I will press R and Ctrl R. Let's see how it goes. Okay, it did it. So you see, I can send this to as a blocking to my level designer. That way they know how tall the guards are. They can place and play with it. So I will do this.
How in geometry nodes, if you instance objects onto other objects, like if you're scattering something around a terrain or a character, it technically doesn't exist as real geometry until you add a realize instances node. So I would consider anything before realizing instances virtualized until it's created. So that's my definition. When we're observing mathematically constructed shapes in 3D space, like with CAD modeling or with SDFs, whether they're in the shader editor geometry nodes or through an add-on, creating things in the 3D view, I consider them virtualized techniques, where until they are converted down into actual polygonal mesh objects, they are technically just like ethereal. Metaballs are a bit different because from my, again, kind of limited understanding of metaballs, they're more of a voxelized technique where if you imagine a hypothetical three-dimensional grid that's invisible in the space, when you have objects representing a positive influence in that grid, you kind of draw a shape between the points. So when they come together, you can see connecting points, but they're they're a bit snappy and weird, and you can almost kind of draw out where those points are, like marching cubes. You know, you think about Minecraft, or when you kind of cellulize shapes like that, like with voxel remeshing or remeshing, with the cube method. The creation of a grid is a very apparent part of that, and it feels like when you are meshing voxels, it doesn't matter how much detail you put into it, you're always going to see a little bit of like a bumpy grid. It's a bit weird, and that's always going to be a bit of a limitation, right? Because even with SDFs, when you're converting down into a mesh, you still need to choose a remeshing technique, and each of those is going to have pros and cons, so you're going to lose some detail. But I think the important thing about this method is that up until the point where you want to realize the shape, you have something perfect, which cannot be said for every modeling technique. For example, the way I imagine this working in the future for my workflow is that if I wanted to do some hard surface concepting, some product design maybe, stuff that could be printed out in a 3D printer or sent off to be formed, I would have in my mind a component room and a modeling room. And the component room is where I would express and design components in a mathematical way with SDF modeling or an alternative, you know, like NURBS computerized method, something that is inherently perfect and mathematically expressed. And then when I want to use it, say if I want to convert it down to a mesh, who knows, maybe for like importing in a game engine or something, then I would do that. That would be the destructive transition. Now we're already kind of familiar with this workflow because a lot of you out there use subsurf modeling, and you think, okay, well, how is this different from subsurf modeling? Because we can change the number of subdivisions and just increasing it until we get our infinitesimal quality. Even with kit bashing, you see a lot of kit bash packs online, and a lot of the hard surface ones will say works with subsurf modeling, where the components of the kit bash pack have been designed to increase and decrease in levels depending on what you need. You'll see this a lot with like the visual effects industry, because you want to be able to control the quality level of your objects. The thing is, subsurf modeling is a lie. I should put that on a mug. Subsurf is a lie. Because of this, I've got another marble paperweight here. So subsurf modeling is kind of like weird, semi-virtualized thing. When we think about modifiers in Blender, I would consider the modifier output to be virtualized before it's applied, in which case it becomes real. But every subsurf object looks like this. There is no such thing as a perfect curve. When you look at the surface of an object with a subsurf modifier, you will see facets. And then if you increase the levels, it might look perfect, perfectly smooth and round. But then if you zoom in again, you will see more facets. So you increase the levels again, zoom in, and then you'll see more facets. And then you increase the level again, and so on and so forth. So it's not exactly the same. Plus with subsurf, you have to deal with all those transition issues which we talked about with the Booleaning. So basically all of this is to say that in the 3D modeling world, there's quite a large demand for freeform, lossless modeling. Preferably somewhere between polymodeling and sculpting, which is where 3D Code's done a pretty good job as a software, but it's still kind of heavily relying more on voxelized methods, voxel modeling, live voxel modeling, converting down into surfaces as they call them, which is just polymodeling. So let's go back over to the computer. We'll take a quick look at the Conjure SDF add-on and what's going on with it. Then we'll talk about our sponsor. You can get a free add-on, and then we'll close things up. Okay, hello again. So over on Twitter, we have again John Kaz Art here, who's been developing the add-on. They are a tech artist for Rycon Official game development studio. So if you scroll down, we'll see some examples of meshes that are made using the add-on in a beta/alpha capacity, in this case to be converted down to mesh. So this is someone who's used SDFs to build a shape and then convert it to the mesh, and you can see some of the limitations here of converting to meshes as part of a remesh technique, but the forms are very organic, very fluid in the way that they're merged together. People that have done voxel modeling in the past will be quite familiar with the look of this. With SDFs, you can worry about design and shape first and foremost, and then worry about the geometry and topology second. That's the whole point about this. Notice here, these are shapes which would be very difficult to achieve with traditional polymodeling, these cylindrical shapes blending into other curved surfaces. Here we can see how taking something mathematically expressed and converting it down into a mesh presents some technique issues. Using a basic marching cubes algorithm, runs on the GPU as a compute shader, churns through 2 million voxels in a matter of seconds. That's impressive. Very close to full integration now. So we have a raw conversion of SDF to mesh, and then we have a remeshed and smooth version. It can come out to be a lot of geometry because, again, when you're taking something infinitesimal, you can pretty much add as many points or as few points as you like. Now, this is a demonstration which I think is really going to sell the idea to hard surface concept artists, because one of the limitations we bump into when doing some of these esoteric methods, like using metaballs for everything, is not only is it finicky, but sometimes it also gets quite slow. And being able to see here how a complex hard surface shape is being smoothly modified is really, really impressive. So again, in my mind, for like an ideal hypothetical work environment for this kind of model concepting is I would have a component room where I'll do this kind of work, and then I'll have my modeling room where I will convert that down into a mesh and then use that to do other types of artwork. And then hypothetically, if this is like a widely used thing, widely regarded, elements in the component room could then be shared with other people. So this would effectively level up the game for kit bashing, because when sharing kit bash objects between other people now, you don't necessarily know like the quality level or whether things are going to be compatible with subsurf modeling, but having SDF kit bashing, that could be a game changer. So what about native integrations? Well, even though this add-on is being worked on, there are people that are looking and working on natively integrating SDF modeling as part of the Geometry Nodes toolkit. It's kind of something you can do already-ish, again, not my field of expertise, but it makes a lot of sense to have SDFs as like a native integration for Blender. But again, it might be a bit too soon to talk about that, and I don't really know what's happening behind the scenes. I just thought this is something you might be interested in learning more about, because it's got quite a few people excited in the community. So now we're coming to the end. I'm going to let you know about something you can get your hands on now, a free add-on, as well as a paid one, from our community sponsor, Spencer Magnuson. Now, Spencer is actually the second person to make use of our casual sponsorship system. The first one is still waiting for something to be released. But what Spencer wanted me to show you was a couple of their add-ons. So first of all, we have the NView add-on, version free at the moment on Blender Market. NView is an add-on for optimizing scenes based on what can be seen by the camera. So this is all about trying to decomplexify your scenes if you're working with a lot of objects, which can be a little bit annoying having to enable and disable things in your collections just to try and speed things up. I do that all the time. It saves on rendering time without compromising anything visually. So you can automatically hide and disable collections or objects that reduce your performance without affecting what's seen by the camera. So if you're interested in optimization, it's a really handy tool to have available. Supported in all render engines, interacts with all of the object types when doing this, and works in both perspective and orthographic, which is impressive. And quite interestingly, here you can bake object visibility to keyframes. So instead of having to have it calculate things every time, sorry, my camera died, you can bake the optimization down, which I think is really handy. I don't know if anyone's ever come up with that idea before, but it's worth checking out. You can also mask out geometry outside of the camera view, which is kind of interesting. This reminds you of like, well, this is a form of culling, right? I wonder how much of a performance difference that makes. What about objects visible in reflections or behind transparent objects? You can preserve those too. Now that's clever, because that is something that game engines often fail at doing in terms of optimization. So from the looks of it, it sounds like Spencer has really spent quite a lot of thinking effort on getting this set up. But I did also promise you a free add-on. So again, from Spencer, I think about it this way: how many sponsors from other YouTubers get you free stuff you can actually use? So Light Painter. This is an interesting one because as far as I understand it, Spencer made this after watching one of my earlier tutorials about painting with light or drawing with light. So I'll show a video they prepared on the screen here. What Light Painter allows you to do is it lets you draw with the annotation tool, I believe, where you want lights to affect your objects, and then the add-on will automatically create a lighting setup to make that possible, if that makes sense. So watch here, you can draw down the side of your character and then lights will appear. I really like this bit where you can draw light onto a phone screen and then it appears and then emits onto the character's face. It's a really interesting concept for an add-on, and again, this is free. You can go and download it. I'll leave a link to the repo in the description. Spencer is a lovely community member as well, so if you want to follow them, I will leave their socials here. Quite easy to remember, spencer.magnuson. So they're on Instagram and Mastodon as well. So yeah, very useful. So thank you, Spencer, for making use of our casual sponsorship system.
So I exported it. So you select it, you do export FBX. There. For now, keep with the just take the selected. We will see how it comes out in Unity with the settings as default, and then we will do back and forth if it's not like as we want. We will import it there. I don't remember. So I put it in an output folder. I put all my output in this folder. Usually I do this kind of folder for anything that I'm ready to play with. So I think the best way to do it is to open the folder and right click on the folder, models, go in Explorer. Then it won't show in Explorer. You will need to double click it and then paste your FBX. Go back, it will be here, so you can bring it there. It kept the material because it's an FBX. So there are many issues right now that you would want to correct. First thing first, what is height? It's, of course, it's not the right height if we had a cube. Let's add a cube. Create 3D cube, and the cube, let's open the inspector, put it to 0, 0, 0. Okay, the cube goes is in the air. Just want to slow it down. So you press Q E in Unity to go up and down, and you scroll down to make it slower. But you need the cursor to be in the window to slow, and scroll up to make it faster. Something like that is the best. So 0, 0, 0 is there, which is weird. They chose to put it above the grid, which I wasn't used to this. Why did they put it? They didn't put it to... What if I do this? Nothing. Okay, you can move it to handle, but yeah, it was 1, 1, 1. Put it to 0, and then to origin. Okay, that's why it was already to origin. The cube was to 1, 1 at 1, 1, 1. Now you can see that this is 50 centimeter from the middle of the cube to the top, because the cube is 1 meter. So if we would want to have like how can we proceed to... Let's say we would want to have a 2 meter or something. Just average, not the perfect 2 meter, but just correct visual of 2 meter. That would be like a very high for a character. So our character is way too big. It's like like 6 meter or something, more, 7, 8, something like this. So it's almost 4 times the size we want. So let's go back to Unity, Blender, and then there's something we need to do. First, the base mesh was probably too large, the one we picked on the free on the internet. Let's start with the Control A and Alt Transform. This will reset Alt Transform the data back to 0. So let's say you have scaled you scaled like the Y like this, but you want it back to 1, you press Control A, and then 1, it's back to 1. That's what it does. So just to be sure, Control A, Alt Transform. It will still be too large, I guess, if we export it back and then re-import it there. How do we re-import? I don't remember. Double click. No, don't double click. How do we re-import? Don't open this. I think it's right click, re-import. Yes, so nothing changes, I thought. So this would be too large too. So we can see 7 meter there. It fits Blender, Unity. Usually like the one 6 meter. Oh, I was wrong. It's this one. So let's try 1.6 meter. Damn, son. Then you copy this one and you paste it into the others. And then we have right. Press on your numpad. Press the comma, the dot. It will center back with the right scroll speed. Because sometimes you are far away and you scroll and it's slow. You need to press in the numpad on the bottom the dot, so it recenter everything there. So now we do Control A while transform, and then it's back to 1, and then we go export. So I would say this would need to be put in the GDD or TDD depending on how you set yours. I would suggest you to put it in the TDD, technical design, for everything that is for the team, the production, the development of the game. Put it in the technical, and everything that is for investors, put it in the game design document. So the height would be technical because everyone in the team will need to know the height of your cards. So did I export it? Don't remember. Let's re-import. I think not. Let's try this. Re-import. Yes. It crashed. It didn't like my idea of re-importing. I don't know if I pressed the right thing, but let's see. I'm a bit cold. I would need to go up and put a bit of heat. And I will do that now. I will take a little break, fill my glass of glasses, ice glass. Okay, so we'll take a break. Be back in a few minutes. Okay, so it doesn't seem to work. I don't want to save this because they are merged. I want to merge the merged version. It's not done for me. But I don't have much time. I can only do it within the live stream with you. So it's exported, but when I do re-import, it doesn't move a bit, so I will delete it. And oh, it's because it's not linked to this one. So if you want to import, click import and it linked it, you would need to import it from here. So navigate, it doesn't want to go there, so I will copy the path, paste it, not import. So now every time I will export, it will check the position. So now the issue is that it's looking down and on the floor. You don't want that. And to correct this, it's the export FBX. I don't understand why it changed. Probably because of the Control A reset. But you see that the up it's Z, and we want it to become like in Unity. So it's Y up in Unity. Y up. But we are Z up here. And Y is back. So the Y up, it isn't back. So let's Z up. Let's try this. Export, re-import. It doesn't move a bit. It doesn't move at all. It's too tired. It's too tired. He's annoying me. Control A and from all. Export. FBX. Minus X forward. Let's say Y forward. In ZBrush, in Unity, the forward I would like to have is Z forward. Let's try this. X up. That was X up. It's Y. Y up. Z up. Let's retry Y up and Z forward to see. And re-import. That doesn't move a bit. I don't like this. I will delete it and re-import. There's something wrong. Maybe it needs a save. I will save anyway. Export. layout, export FBX. There is another FBX down there. It's for Unreal. It's a add-on that I used. Placeholder selected. Apply unit. Apply transform. It's the same as Control A, but they have a warning. Z forward. I want to Z forward. I want the Y up. Re-import all. I didn't change a thing, so. Oh, I remember it doesn't like re-import all. It crashes. So, how can we do? Let's see what do people say about the render to Unity export FBX. I want something recent. This one seems to be recent. I already clicked this one. It's an old one already.
Maud adore le pad thai.
Maud likes pad thai. When someone say pad thai in French, it's some kind of dish recipe. Pad thai. It sounds like you are not the how to say that. French would say height thigh, like the waist thigh. But we use the same word as the waist in English, which is thigh in French. We also use it as height. La taille de someone's height. We say la taille de quelqu'un. And yes. And pad thai is a plate. The dishes. Pad thai, Thailand. And it sounds like an expression in French. We say il n'est pas de taille, which means it's not strong enough. Pad thai. And it always rings a bell when someone says pad thai. Pad thai is not strong enough. Pad thai. So what does
versions of Unity? You can FBX
what does
at the FBX exporter for Unity, and I didn't know this was there until recently, but this might be something for you. And if you've got an asset or a model within Unity, whether you've created something yourself, it might be a beautiful work of art, and you want to export this out to use in Blender or any other 3D program, I'll show you how today. So be sure to check out my Patreon to get access to over 120 different scripts, projects and assets you can't find anywhere else. And be sure to check out my great assets on the Unity store and my website for bonus discounts. So when you're in Unity and you have yourself a model, you can go to Window, Package Manager, and if you select by Unity Registry and search FBX in the corner, you will get
I never used this. it might be good. Exporter? No.
Get the FBX exporter, and it'll be in this version. It's version 4.1.2, and I'm using Unity 2020.3, and it is available across most versions of Unity. You can just click to install, and once that's then installed, you can select any 3D object, like say this vehicle that I've got here, and then what you could do is you can right click that asset in the hierarchy, whether it's made up with lots of children or not, and you can just go to
I misread the title. It's from Unity to Blender. This one is too old.
Dernière fin de semaine de la grande liquidation.
Last weekend of the great liquidation of Leon's. It's furniture, home furniture stuff.
Only to have it come with weird rotations and scale. Here's how you can easily fix that issue, as well as what you should care about when exporting your models. I have a simple shield model here. First, make sure you have applied your transforms to have the correct rotation and scales for your object. Select the object, press Ctrl A and select rotation and scale.
I'd say all, but you can do rotation and scale if you want, because scale would be usual when you move scale up. Location can be, so all would be.
The model. Make sure the object is selected, go into File, Export, and choose FBX. Turn on selected objects to export only the selected objects. Then click on Mesh to make sure you are exporting only meshes. Under Transform, select Apply Transform. This will fix the scale and rotations from the models inside Unity. If your object is facing Blender's front camera, you don't need to change the Z-forwards direction. You can deselect Bake Animations if you have animations you don't want to export. You can leave the other options as they are.
Okay, so he left it Z minus Z forward, Y up. And let's try this. I don't want to install this. Export it to FBX. Select export FBX. Minus Z forward, Y up. Minus Z forward, Y up. Apply and mesh. Let's do this too. Anything else? No. I will try to rename it to just to have clean. And if it doesn't work, then I'm cursed. Import new asset to. Yes, it seems to work. It could be because this one was rotated. Yes, it worked with the old one. It was rotated face down. That's why. So is the right size. You can see this is 2 meters. He's 1.6 meters, like a tall guy. Not 6 foot, but just like almost my height. So that's fine. That's fine enough. It's not tall. Tall is medium size, I would say. So now the animators can use it. Animators, the level designers. For instance, they can already animate it with by putting a script on it and anything. What is this shadow? You can press shift to go faster. So that would be it for placeholder base mesh. how you would go. If your guys say it's too heavy, can you lower it? You just have to. You can. This model will be prone to crash. It will be replaced. It's the name. That's why the name placeholder is holding the place until a new version is available. Then you can iterate like to give comfort to your team, and you can upload the new version every week. That way they have some kind of feeling of encouragement, and you can present the game with a better look every time. So that will be it for tonight. For this, should I could keep it short that way? I think yes, I can keep it short. Yeah, I will keep it that short and iterate over next sprint. When I will go back to the characters, I will save that. So that would be it. Basemesh. What can I say? Basemesh is usually more for the character artist, but it can be anything. Prop artist. Let's see if props artists use Basemesh. Probably. Yeah. Oops.
Hello everyone. It's been a little while. I've been working on 3D December, which is like a daily challenge to do.
I use 3D Code. It's good software. It's a paid software, but it was fine.
3D Code. And here's the first screen you're gonna start with. And I'm just gonna go voxel sculpting. And I'm gonna start with clean window, so get that. And the first thing I'm gonna do is I'm gonna go up here to the top and toggle between isometric and orthographic. You'll notice isometric normal perspective view is like this, and we want the one where it's kind of gradient. If you don't, height of the barrel. And from there we're gonna start modifying this curve. So I'm gonna go on here. Oh, and on the right side of my screen here, you can see these are my references just from previous. Might have to turn this back into this mode. Let's see if I actually did it. Yeah, see, it doesn't do it because it's in ghosting mode. And that looks pretty good.
He's doing Boolean.
I'm gonna actually to regular, and we're gonna say
subtraction.
Banding. And also leave. Let's do a little more. Oh wow.
So that would be it. You have a base mesh. The base mesh is the block. Usually, character artists will make their anatomy first. They will do like a turntable like that. I don't remember the name. There are multiple names for spreadsheet or turntable, rotation table. So that would be it. And then you can sometimes you can ship this to the level designer, and the same just like I did. It's also used that way when you want to start from scratch. You can start with Basemesh given freely on internet. You can buy Basemesh to start all your models. But it's usually just a block from which you can give a version to the first iteration for level designer, and another version that you will make better. So that will be it. Thank you for watching, and if you want to support me, there's a link in the description to my Patreon and tipping platform. Oops. So tipping platform, and that will be it. Tomorrow I will be going over next thing. Level design a bit, yeah. Concept art, the level. This is a bit done with the first one above. So that will be it. Thank you for watching. To see you tomorrow.